So next topic is balancing of redox reactions. So already redox reaction we know both oxidation and reduction takes place simultaneously or said to be redox reaction. So in this redox reaction is calculated, balancing the redox reactions takes place by two methods. One is oxidation number method. One is oxidation number method, another one is ion electron method. Another one is ion electron method. So now we are going to see first method, oxidation number method. So in this method, oxidation number of elements before and after experiment is calculated by using electron lost or gained in the reaction. So oxidation number method is going to calculate oxidation number of elements before and after the experiment by using electron lost or gained in the reaction. So it has following steps. So these are the steps for oxidation number. So first step is going to calculate oxidation number of an atoms in the equation, and second step we have to find out which atom undergoing change in oxidation number. So first step oxidation number of an atom we have to find out, and second step which atom undergo change in oxidation number you have to find out, and third step is balance the number of atoms that undergoes change in oxidation number. That means which atom is undergoing change in oxidation number is that atom we have to balance first. That's why we mentioned balance the number of atoms that undergoes change in oxidation number. And fourth step is calculate the total change in oxidation number for oxidation and reduction. So you have to find a total change in oxidation number. The next step is balance the total increase in oxidation number is equal to total decrease in oxidation number by multiplying with suitable integer. So you have to balance the total change in oxidation number by multiplying with suitable integer. And next step is balance other atoms except oxygen and hydrogen. And last step, first hydrogen you have to balance and then you have to balance oxygen. So these are all the rules, so steps for determining oxidation number. So using these steps you will see one problem. It is in the exercise problem. Example problem they given KMnO4 plus FeSO4 react with the sulfuric acid to form Fe2SO4 thrice MnSO4 plus K2SO4 plus H2SO4. So in this equation going to calculate oxidation number of the element before and after the experiment by using electron lost or gained in the reaction. So using that we are going to balance this equation. So first of all already we know how to calculate oxidation number. So already we know potassium is +1. Oxygen is -2. When you substitute this equation, you can calculate oxidation number of manganese is +7. Oxidation number is -2. So 4 into -2 -8. So in this we know how to calculate manganese oxidation number. KMnO4 means this is X. So 1. Potassium oxidation number is 1 plus 1 manganese, so 1x plus 4 into -2 equal to 0 because no power. So 1 plus x minus 8 equal to 0, x minus 7 equal to 0, so x equal to 7. That's why here manganese is +7 oxidation state. So manganese is +7. So already we know FeSO4, so iron in +2 oxidation state. So obviously SO4 is -2 oxidation and H2SO4 hydrogen is +1, here 2 hydrogen, so it is +2. sulfate already we know it is minus 2. So in this case, when you calculate oxidation number for iron, it comes as plus 3. You try it in homework. The SO4 already we know it is 2 minus. So 3 into 2, 6 minus. If multiply 2 into 3, 6 plus 6. So plus 6 plus minus 6, the molecules become neutral. So in this case, manganese sulfate SO4 2 minus 2 we go right hand side means become plus 2. So manganese is plus 2, SO4 already we know it is minus 2. Potassium oxidation number is 1, so 2 into 1 plus 2, SO4 is minus 2. Here hydrogen we know it is plus 1, so 2 into 1 plus 2, oxygen is minus 2. So from this element, first step we calculated, determine the oxidation number of equation. Second step is identify which atom undergoes change in oxidation number. You see, manganese become plus 7 to plus 2. Manganese is undergoing change in oxidation number from plus 7 to 2. And you see iron is changes from plus 2 to plus 3. So iron atom is undergoing changing from plus 2 to plus 3. So if it is plus 7 to means it gains 5 electrons. So gain of electron is reduction. In case of plus 2 to plus 3, it loss on electron, it is going to go oxidation. And next step is we have to balance the number of atoms. Balance the number of atoms that undergoes change in oxidation number. So we have to balance. So manganese is left hand side 1, right hand side 1, so it is already in balance. In case of Fe, left hand side 1, right hand side it is 2, so put 2 Fe. Okay, so right hand side 2 iron Fe, so left hand side, so put 2 means 2 Fe, it is balanced. Next, you have to find a total change in oxidation number. It is an important step because already we know iron is in plus 2 oxidation state here. Here iron is in plus 3 oxidation state. When you multiply 2 into plus 2, so iron is in plus 4. Here 2 into 3 plus 6. So iron is converted to plus 4 to plus 6 because we are considering total change. Total change means already we know oxidation number for iron plus 2. This number plus 2 is multiplied by 2, we get plus 4. Iron already we know oxidation number is plus 3. Because of 2 iron, you multiply this 2, multiply with the 2, we get plus 6. Manganese, same, already it is balanced, so it is converted from plus 7 to plus 5. So we calculated total change in oxidation number. Remember, this step is very, very important. Once you have done the mistake in this step means definitely the next step will not get the, finally we didn't get the answer. And next one is we calculated the total change in oxidation number, and fourth step is balance the total increase in oxidation number is equal to total decrease by multiplying with suitable integer. So in this case, plus 4 to plus 2 means iron difference is 2 electron, loss is 2 electron, plus 7 to, plus 2. So plus 7 to plus 2 means difference is 5 electrons. So you have to balance this 2 and 5. When you multiply this number with the 2 means we get 10 electron. Same we have to get 10 electrons. So you have to multiply with 5, we get 10 electrons. So it balances the total change in oxidation number. Total decrease. Balance the total increase in oxidation number by is equal to total multiply with suitable integer. So we get already balance 10 electron, 10 electron. Next step is very important. So already in the previous equation, balance it is 2 FeSO4. So in this case, iron we multiply the difference with the 5. So wherever iron present in the equation, you have to multiply with 5. Similarly, for manganese, we multiply number with 2. This 2 is multiplied with manganese wherever present in the equation. So already Here manganese present, so manganese is multiplied by 2. So if we multiply by 2, we get 2 manganese. Then here iron present, so iron already we have 2. When you multiply with the 5, you get 10 FeSO4, because here my difference is, so iron is multiplied with the suitable integer 5. So this multiply with the 5, we get 10. So here iron present, so you have to multiply with 5. Already here 1 is there, so 1 into 5, 5. So here manganese, you have to multiply with the 2 over. Here only potassium, so no either manganese or iron. So balance everything. Next we have to balance other atoms, other than except oxygen and hydrogen. So we check, so potassium K2. Here K2 balanced, iron is 10 balanced. In case of manganese 2Mn, so manganese is also balanced. But you have to see sulfur, S. So sulfur here 3 into 5, so S is here 15 plus 2, here plus 2, here plus 1. So total 18 sulfur on reactant side. But in case of product side, in case of reactant side, S is 10. So we have to multiply this by 8, then we get 18. So sulfur is balanced. So 10, you have 1 sulfur, and you multiply with 8, you get 18 sulfur. Next step is, you have to balance, I said, except oxygen and hydrogen, but first you have to balance hydrogen, then only oxygen. Here you see hydrogen, number of hydrogen, 8 2s are 16. So put 8 here, so 8 2s are 16. So hydrogen is also balanced. Last step, we have to balance oxygen. Oxygen on reactant side, you see 2 4s are 8 plus 10 4s are 40 plus 8 4s are 32. When you add, you get 80 oxygen on reactant side. So you have to balance on product side. Product already 4 3s are 12. 12 into 5, 60 oxygen plus 2 4s are 8 plus 4 oxygen plus 8 into 1, 8. When you add 60 plus 68, 72, 80. So 80 oxygen. 80 oxygen. So the equation is balanced. So this is how you should try for remaining. So book back from you try, except the third one. Third one I will tell you how to do the third one exercise. Book back 44. 44th question. You try all the exercises except the third one. Third one I will tell you in another video. So it's all about oxidation number method. Suppose you have any doubt, you can ask me in the comment box.